Hello and welcome back to my channel. Today in this video we are going to discuss the question number 5, 6th and 7th of March 2025 9709 paper 3, that is 3-2, and here is the question number 5. The square root of -4 plus 6 root 5 iota can be expressed in the Cartesian form x plus iota y, where x and y are real and exact. By first forming a quartic equation in x or y, find the square roots of -4 plus 6 root 5 iota in exact Cartesian form. Let the square root of -4 plus 6 root 5 iota be x plus iota y. It means if x plus iota y gets squared, it has to be -4 plus 6 root 5 iota. So if I expand it, it is x squared minus y squared plus 2xy iota equals -4 plus 6 root 5 iota. Now equating real and imaginary parts, we will get x squared minus y squared as -4, and for imaginary parts 2xy equals 6 root 5, which can be simplified as xy equals 3 root 5, from where we get y equals 3 root 5 over x. Now we plug it in the real part, which says x squared minus 45 over x squared equals -4. If I multiply it by x to the power 2 throughout, we will get x power 4 plus 4x squared minus 45 equals 0. Factorizing which, we will get x squared plus 9 x squared minus 5 equals 0, from where we get the x squared equals -9, which is of course not real, or x squared equals 5. So from here we get only x equals plus minus root 5. And when we'll plug this value in the y equals 3 root 5 over x, we get y as 3 root 5 over positive root 5, which gives you 3, and y equals 3 root 5 over negative root 5, which gives us -3. Means the square root become root 5 plus 3 iota and negative root 5 minus 3 iota. I hope it is clear. Let's discuss the next question now. Here is question number 6. The variables x and theta satisfy the differential equation dx over d theta as 1 over 5 times x plus 1 times sine squared 2 theta, and x equals 5 when theta is 0. Solve the differential equation and obtain an expression for x in terms of theta. So let's discuss the solution of it. So the given differential equation we have is dx over d theta equals 1 upon 5x plus 1 times sine squared 2 theta. So we can see it is going to be done with the help of method variable separable. So we will rewrite this differential equation in that form. We are going to send 1 over 5x plus 1 to the left hand side, and we get this differential equation as 1 upon 1 over 5 times x plus 1 times dx over d theta equals sine squared 2 theta. And integrating both these sides, we can rewrite this thing, the whole equation, differential equation, as 1 upon 1 over 5x plus 1 dx, because it's a terms of x, and sine squared 2 theta. We don't know the direct integration of sine squared 2 theta, so we are going to use the double angle of cosine x. So cosine 2x is 1 minus 2 sine squared x, which means sine squared x is half minus half cosine, double of the angle. So from here the x can be replaced with 2 theta, and we will get sine squared 2 theta as half minus half times cosine 4 theta, because x is 2 theta. So replacing this in the differential equation, we get integration of 1 upon 1 over 5x plus 1 dx equals integration of half minus half cosine 4 theta d theta. Integrating which, we get 1 upon, because the coefficient of x is 1 upon 5, so 1 upon 1 over 5 times ln 1 upon 5x plus 1 equals half theta minus 1 over 2 times 1 over 4 times sine 4 theta plus c, constant of integration, which we can rewrite as 5 times ln 1 upon 5x plus 1 equals theta upon 2 minus 1 upon 8 sine 4 theta plus c. Now we'll use the given condition, which says x is 5 when theta is 0, and we know sine 4 theta means sine 0, that is going to be 0. So left hand side become 5 ln just 2 equals to 0 plus c. So c become 5 ln 2, and replacing this, we can write this whole thing as ln 1 upon 5x plus 1. 5 we can transfer to the other side, so it becomes 1 upon 5 theta upon 2 minus 1 upon 8 sine 4 theta plus ln 2. Means we can write 1 upon 5x plus 1 as exponent of the whole thing on the right hand side, which means it is going to be we can take it as the a to the power m plus n, and splitting it into two parts or combining it as a power, we can write e to the power ln 2, which is just 2. Hence we got this whole thing equals 2 times e to the power 1 upon 5 theta upon 2 minus 1 upon 8 sine 4 theta. We can multiply 1 upon 5 inside, and sending this 1 to the other side as well as 5 to the other side, we got x directly as 5 times 2 e to the power 1 over 10 theta minus 1 over 40 sine 4 theta minus 1, means x equals 10 times e to the power 10 theta minus 1 over 40 sine 4 theta minus 5, and that's the answer where we got the x in terms of theta. I hope it is clear. Let's discuss the next question. And here is question number 7. The diagram shows the curve y equals x cube cosine 2x for x greater than or equals to 0 and less than or equals to pi over 4. The curve has a maximum point at m where x equals p. Show that p satisfies the equation p equals half tan inverse 3 over 2p. So let's discuss the solution. So here the equation y equals x cube cosine 2x has a maximum point at x equals p. So the derivative at x equals p is 0, means dy over dx at x equals p is 0. Now we are going to differentiate it with the help of product rule. So dy over dx is going to be x cube times derivative of cosine 2x, which is negative 2 sine 2x, plus cosine 2x into the derivative of x cube, which is 3x squared. So at x equals p, this whole equation, this whole expression will become 0. So at x equals p, negative 2p cubed sine 2p plus 3p squared cosine 2p is 0, which can be rewritten as 3p squared cosine 2p equals 2p cubed sine 2p, which is, after cancelling p squared from both the side, we get 3 equals 2p times sine 2p over cosine 2p, which makes it 2p tan 2p, and from here we get tan 2p equals 3 over 2p, which means the angle 2p become tan inverse of 3 over 2p, from which we can get our final answer, which we need to show, that is p equals half times tan inverse 3 over 2p. I hope it is clear. Let's discuss the next part. B part is show by calculation that p is greater than 0.5 and less than 0.7. So we'll make the equation from the previous part and check their sign. So let's define from the first part f of p as p minus half tan inverse 3 over 2p, and then we'll find the value of f at 0.5, which is going to be negative 0.12452, which is negative, and the last value, which is 0.7. So f of 0.7 is going to be 0.7 minus the same value. We'll get it from the calculator, which is positive, and they have the different sign. So we can say that the root p lies between 0.5 and 0.7. I hope it is clear. Let's discuss the next part. This is the last part. Use an iterative formula based on the equation in part A to calculate p correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Let's discuss the solution of it. So from the first part, we have seen p equals half tan inverse 3 over 2p. And from the second part, we have proved that p lies between 0.5 and 0.7, from where from A part we can define the iterative formula p of n plus 1 equals half times tan inverse 3 over 2pn. And we can take the initial iteration p naught as 0.6 between 0.5 and 0.7. From here we get the p of 1 first iteration, and we get this as 0.59514. So from here we get the second iteration just by plugging this value in place of pn. So that next iteration is going to be 0.59654, and then from here we can get the third iteration, that is 0.59614, We can see it is correct to three significant, the correct to three significant value, the p value is 0.596, but just to make sure we can write till 5 iteration, and fourth iteration is 0.59626, and then fifth iteration is going to be 0.59622. So from here we can easily say that p value approx close to three significant figure is going to be 0.596. So that's it for this video. I hope it was helpful. Let's meet again in the next video. Thank you so much.